A math teacher kicks a ball into the air. The height y in meters above the ground of the ball is modeled by the equation y equals x times the quantity x minus 1.37, where x is the time in seconds since the ball was kicked. Find the roots of the equation. Explain what the roots mean in this situation.
Hello, Math 2 students. It's time to learn about modeling with mathematics. As you saw the video of the math teacher kicking the ball, you probably thought of a few questions. How high can the math teacher kick the ball? How far can the math teacher kick the ball? How long was the ball in the air? Well, between the picture taken from the video and the graph, we can answer all of those questions. So first of all, from the picture taken from the video, we could start from where the math teacher kicked the ball, and we could go to where the ball hit the ground. And if we measured that distance, we would be able to tell how far the math teacher could kick the ball. If we measured from the top to the ground, we could tell how high the math teacher kicked the ball. But the graph tells us different information than that. The graph has a y-axis that is measuring height and an x-axis that is measuring time. So the picture would allow us to measure the distance the ball traveled and the height of the ball. The graph allows us to measure the height of the ball and the amount of time that the ball was in the air. So the blue dots are tracing the path of the ball on the picture, and the blue dots are tracing the height as time passes on the graph. So before time ever started, when time was 0, we can see that first blue dot represents a height of 0. And as you can see by watching the movie, the ball went up into the air, and eventually the ball came back down to the same height of 0 that it started with. That would be this location on the graph. The confusing thing about this location on the graph is the computer was not able to generate a dot right on the x-axis. So we don't know the exact time when the ball hit the ground. So to answer the question, how long was the ball in the air, we're going to need to do some calculations. The information that was on the screen told us that the flight of the ball can be modeled by the equation y equals x times the quantity x minus 1.37. Now, one thing that we need to modify about this equation is y stands for height. But in order to find out how long the ball was in the air, we really only want to consider one height. The ball was at a height of 0 2 times. It was at a height of 0 before takeoff, and it was at a height of 0 on its landing. So I'm going to replace the y in the equation, which is representing height, with the number 0. So I have 0 equals x times x minus 1.37. And this is an equation that is in factored form. And I can use the zero product property to solve this equation. So we know that this x in front of the parentheses is going to give us an answer of x equals 0 seconds. And this part of the equation is going to give us an answer of x equals positive 1.37 seconds. So in the problem on the screen, it asks us to find the roots. Those are called the roots of that equation. And it asks us to interpret, what do those roots mean? Well, those are times in this problem. So the 0 obviously represents the time when the ball had a height of 0 before takeoff. That's this point here. And the 1.37, that is the time when the ball hit the ground. So this unknown time that we were looking for right here, when does the ball really have a height of 0 and there was no computer generated dot to tell us? By finding the roots of this equation, we were able to tell that at exactly 1.37 seconds, that is when the ball returned to a height of 0. So how long was the math teacher able to keep the ball in the air? He was able to keep the ball in the air for 1.37 seconds.